Today we are going to be talking about 3E, which is determining the types of solutions and number of solutions of a quadratic equation by using the discriminant. Mine is going to be on page 30. Remember, yours might be on a different page number. Just continue in your notebook. You're going to pick up this piece of paper in class, and when you do, I want you to go ahead and cut off the bottom two examples so that we have a little bit more space to write as we move through our examples. So today we are going to be talking about determining the, and this is 3E. We are going to be talking about the type and number of discriminant. The discriminant is actually a part of the quadratic formula. Basically what it does is it allows us to solve what's inside the square root and determine how many solutions we have. So when we're solving the quadratic formula, we have a little bit more of an idea of what we are looking at. So the equation or the formula for the discriminant is b squared minus 4ac. And remember, that comes from our quadratic equation where we are looking at ax squared plus or minus bx plus or minus c. So the b is the second term, the a is the coefficient of the first term, and the c is the constant at the end. So as we go through this, we're going to see what information does this provide. The discriminant is going to be labeled as d. So d is equal to some number. If that number is greater than 0, meaning it's greater than 0 and a perfect square, it's going to tell me that we have two real and rational roots. So I should have two answers. If that number is greater than 0 but not a perfect square, so it's some other number, not 4 or 16 or 9 or 25 or so on and so on, we're still going to have two roots. It's just that they will be irrational. So their decimal doesn't end. It's not a perfect number. It's going to be a decimal value. If for whatever reason our d value underneath the radical is 0, that means we actually have one root, and it is going to be real and rational. And then if the d underneath the square root symbol in our quadratic formula is less than 0, that means it's a negative number. We're going to have two roots, but they are going to be imaginary. And we're not going to talk about imaginary numbers this year. You'll talk about them next year in Algebra 2. But what we are going to say is that they are not real solutions. So whenever we have a negative number as our discriminant, we will write down that they are not real solutions. So what we're going to do is we're going to take a look at 4 examples, and then you'll have lots of practice in class to do these as well. So we want to leave that formula visible. So again, remember that everything needs to be on the same side of the equal sign, just like when we're factoring. But these problems, we want to figure out how many number and the type of solutions that we'll have. So remember that A in this case is 2, B is 12, and C is negative 13. We want to assign the value, the positive or negative value, along with the problem itself. Okay, so I'm going to use pencil, so in case I make a mistake. So D is equal to b squared, so that's going to be 12 squared, minus 4 times a, which is 2, times c, which is negative 13. So when I square 12, I get 144. And then I'm actually going to go ahead and I'm going to multiply all of this together. So -4, 2, and -13. And because this is a negative and this is a negative, I actually get a positive 104. And so when I add those two together, I get that D is equal to 148. 248. And so as we can see, 248, if I wanted to double check to see if it is a perfect square, which it's not, but I can always use my calculator to take the square root of 248, and you can see that it's a rational number. So it's an irrational number. It doesn't end, it's decimal value. So this tells me that I have two roots and that they are irrational, meaning I will have decimal answers for this. Okay, so let's take a look at number 2. And just so you know, it is okay to have negative values. So in this case, A is -1, B is 16, and C is -64. So our D is equal to B squared, so that's 16 squared, minus 4 times A, which is -1, and B, which is -64. And so 16 squared is 256. And then again, I'm going to multiply -4 times -1 times -64. And I get a -256. And so when I subtract these, I get that D is equal to 0. And on my chart, if D is equal to 0, that means that I have one root and it is rational. And right now we're not concerned about what exactly those roots are. We're just concerned about whether or not we have one or two solutions possible. Okay, so let's take a look at example 3. Example 3, I've got to do some moving here. My B value, 10x, is on the other side. So I'm going to go ahead and rewrite this as -4x squared minus 10x plus 84 is equal to 0 before I take out my A, which is -4, my B, which is -10, and my C, which is 84. Now I can go through and I can solve this. And we want to remember that D is equal to B squared minus 4AC, just as a reminder. So we have D is equal to -10 squared, remember to put that in parentheses, minus 4 times -4 times 84. So -10 squared is going to be positive 100. And then we have -4 times -4 times 84. So plus 1,344. So when we're done, we see that D is equal to 1,444. And we can take the square root of that just to be sure. And you can see that when I do that, I get a 38, which means that it's a perfect square. And so that tells me that since it is a perfect square, that's my first choice here. So I have two roots, and they are rational, which means they are going to be positive and negative integers. In example 4, we're missing the B value, and that happens sometimes. So what we want to do is we're just going to say that A is equal to 3, B is equal to 0, and C is equal to 24. It's okay to have a 0. That's a number as well. So we go ahead and we say that D is equal to 0 squared minus 4 times 3 times 24. And so D is equal to 0 minus 4 times 3 times 24 is 288. And so D is equal to a negative 288. And anytime we have an answer that is less than 0, we have two non-real solutions, meaning they're imaginary, but they are not real. So we want to make sure that we state that they're not real at this time. We will have more practice problems in class, and then we will move on and talk about the quadratic formula.